Hello, this is a video on the unit circle. I'm going to do this in two parts. So this will be part one, where I'm going to introduce a lot of the vocabulary and talk about what a unit circle is and some of the details with unit circles. You're going to have to change your mindset a little bit because I need you to think about graphing in a coordinate plane, but instead of thinking about it in terms of lines and slopes, you're thinking about moving counterclockwise around a circle. So if you take a look here, when I'm talking about the unit circle, I've got a circle drawn with the x and the y axis right through the center of it. The center of that circle is at 0, 0. So the coordinates of this circle right here, this center right here is at 0, 0. So if I go 1 unit to the right, that would be 1, 0. If I go 1 unit up, that would be 0, positive 1. If I go 1 unit left, that would be negative 1, 0. And if I go 1 unit down, that would be 0, negative 1. All right, the other way to think about that, like I said, we're going around the circle counterclockwise. And so starting at 0 and moving to the left, this arm right here, this radius, that's what I'm talking about moving counterclockwise. So the angle that it makes with the x-axis, that radius, the angle that it makes with the x-axis, that's the angle that we're talking about. So starts at 0, moves counterclockwise, and one full lap around that circle is 360 degrees. So each time you're moving, you're getting bigger than 0. So 1 degree, 2 degree, 3 degree, 4 degree, all the way up to a quarter of the circle would be 90 degrees. So half the circle is 180, 3/4 of the circle is 270 degrees, and then all the way back around where it started is 360 degrees. All right, so there these points all that make up the circle all are have x and a y coordinates. So we can find out those coordinates, and I'm going to show you how to do that, but I want to make sure I get some of the background and vocabulary down first. But that's what a unit circle is, a circle whose radius is 1 in a coordinate plane. All right. This angle right here, we use the Greek letter theta, and I don't want to make that more complicated. It's just a symbol representing an angle. That's an angle created by the initial side, which is the x-axis. So that's if an angle was completely closed and a 0 degree angle, you would have that radius sitting right on top of the x-axis. It would look like a line segment. That's a 0 degree angle, and then it just that arm, that radius, and we call it the terminal side, that moves counterclockwise and opens up bigger and bigger and bigger all the way around till you get 360 degrees. Now, some of you are a little bit concerned about that because, in our heads, we've always dealt with triangles and rectangles and everything. All the angles were between 0 and 180. Well, now when you're dealing with a circle, those angles can measure all the way up to, 360. And what you'll see a little bit later is actually we can have angles that are bigger than 360 and smaller than 0. So that's right here. So if the measure of an angle of theta is between 0 and 360, then we'd say that that angle is in standard position. So it's on this circle. If I gave you something like a negative angle or an angle that's bigger than 360 degrees, we could still treat that like any of these angles in standard position. We just either add or subtract 360 until it's in standard position. So you might be thinking, what are you talking about? Okay, so first things first, let's talk about this idea of a standard position. Let me slide down here onto this to give you a good picture. All right, so again, this is what we mean by the terminal side and the initial side. So the angle right here formed by the terminal side, which is acting like that radius, and then the initial side, which is acting like that x value, those two make an angle and whose vertex is the center of the circle. And that arm opens up counterclockwise and just gets bigger and bigger and bigger. This is what I'm talking about, this idea. So at any time, feel free to pause the screen to take a look. Make sure you get all this vocabulary straight. Like I said, the side, these are like rays. So that ray BC and ray BA are the two sides of this angle. All right, heading back up, there was a vocabulary term that I want to make sure I go over with you right here. Okay, so an angle that is less than 0 or greater than 360 is congruent to an angle in standard position. So this little example right here that I'm giving you, where negative 240 degrees is equal to 120 degrees is equal to 480 degrees. All three of those angles are congruent. They're the exact same measure when it comes to an angle in standard position. So they, when on the unit circle, where that terminal side would land, that point on the circle, that would have the same x and y value as negative 240 degrees, as 120 degrees, as 480 degrees. So the difference between each of these angles, because they look very different, even though they would land on the same place on the unit circle, is just this 360 degrees. So I keep adding 360, or I subtract 360 to get it in between 0 and 360 degrees. So you could just use those full revolutions or full laps around the circle to get you back into an angle that you would prefer, or an angle in standard position. Okay? So again, pause your screen if you need to write down any of those definitions. But we are talking about moving around a circle in a coordinate plane counterclockwise. So that's what we've got going on with that. All right. So let me make sure I get some other details down for you before I get into actually finding out what the x and y value of all these points are. Here's another piece of information that's super important, is this idea of radian measure and degree measure. So, when we were doing right triangle trig in the and earlier in the circles unit, we were trying to we would always have to move our calculator into degree mode from radian mode. So I want to show you how you can convert from degrees to radians, or from radians to degrees going backwards, because sometimes when you deal with circles, the measurements will be in radians. Radians, real quickly, is another way of measuring angles of a circle. And what they do, instead of putting them in degrees, they put them in terms of pi. So if a full lap around a circle in degrees is 360, a full lap around a circle in radians is 2 pi. So you're going to be some fraction of that 2 pi when you're doing the angles of a circle in radians. So if I want to convert from degrees to radians, I'm going to take the degree measure and I'm going to multiply it by pi over 180. If I want to find the radians, I would take the degree measure and multiply by pi over 180. So if I had 90 degrees, I would multiply that by pi over 180 to figure out, well, what is that in radian measure? So 90 times pi over 180, 90 pi over 180, simplify, 90 over 180 reduces to 1/2, so pi over 1/2, pi over 2. So 90 degrees is pi over 2 radians. And you could go forwards and backwards with this. So using that same formula, I could solve for degree measure if I knew radians. I would just have to plug it into the formula and solve for degree. But keep this in mind, because that's how we're going to be able to go back and forth between degree measure and radian measure. And you're going to get reference to each of these angles around the unit circle. You're going to get those in degrees and in radians. So you really want to make sure that you can convert from degrees to radians or radians to degrees. And again, here's an example for you right there, just to make sure you have a sense that pi over 2 radians and 90 degrees are the exact same thing. 2 pi radians and 360 degrees is the exact same thing. And you could check all that with this formula. So again, feel free to pause your screen at any time to write down all the background that I'm giving you. So yeah, just making sure that you're getting this sense of what's going on the unit circle. You have this in your notes quite possibly, and if not, you could find one online, a blank unit circle, pretty easily. So if you take a look at this, I got a couple things that I need to give you before we get too far into how to figure out what the unit circle is. So if you notice that I labeled all of these angles and degrees and radians for you. Notice that this is quadrant 1 up here. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And in green, you can see the positive, positive, or negative, positive, or negative, negative, or positive, negative. And that's referring to your X and your Y value for the points that show up in each of the quadrants. So what I need you to notice is actually each quadrant of this circle behave the exact same way, but they are reflections, rotations of each other. So for instance, this angle 30 degrees in quadrant 1, if you reflected that over the y-axis, then it would behave the same way as this 150 degree angle in quadrant 2. If you reflected over the origin, that 30 degree angle would behave the exact same way as that 210 degree angle. Or if you reflected over the x-axis, that 30 degree angle would behave the exact same way as 330 degrees. So the key here that I'm going to show you in the second part of this unit circle video is how to find all these x and y values of these angles or of these points that are on the circle, and we identify those points on the circle like this point here or this point here or this point here. We refer to those as the angle, like 30 degrees. You can use the 30 degrees helps you find the x and y value of that point. And again, I'm going to show you how to do that in the second part of this video, but I just want to make sure you got a sense on the unit circle as it opens up. These are kind of key angles. And if you notice, 30, 45, and 60, those are all angles of special right triangles. So 30, 60, 90, and 45, 45, 90, those are special right triangles. And we're going to use those ideas to figure out the different parts. But this is the bare bones or the basics of the unit circle. And again, I'm going to teach you in the second part of this video, I'm going to teach you how to find the x and y values of each of these points around the unit circle. Okay, so just to recap really quickly, all the way back up here, the unit circle is a circle in a coordinate plane whose radius is 1, and the angles are between 0 and 360 degrees. And remember, a circle is made up of an infinite number of points, all equidistant from that center of that circle. And we can figure out what all the individual x and y values are by knowing their angle measure and using right triangles to help us figure that out. Remember, theta is the angle that the radius, that arm, that radius and the x-axis make at the origin of the circle. So whenever we talk about theta being 30 or theta being 120 degrees, then that's what we're talking about, is the angle that's created by the radius and the x-axis. Remember that an angle between 0 and 360 is in standard position, but we can find angles that are not in standard position and just convert into standard position by either adding 360 degrees or subtracting 360 degrees. All right, so that's the first part of this. I hope that was helpful. Go back, pause and rewind, make sure you get all the vocabulary down. And that's how we're going to use that information to be able to figure out different angles and how they are equivalent to something in the unit circle. All right, I hope that was helpful. Thank you for listening. Remember, that was part 1. Part 2 is next.